All right, here's how you do problem number one. And when you read the problem carefully, basically it's implying a division problem. And I'm going to change the numbers so you know how to do the division. So instead of 6.4 times 10 to the negative 20th power, I'm going to use 7.2 times 10 to the negative 30th power. And instead of 3.2 times 10 to the negative 23rd, I'm going to use 1.8 times 10 to the negative 32nd power. And basically what I'm going to do here is I'm going to divide the coefficients, so the 7.2 with the 1.8. Using a calculator, you're going to see you're going to get 4. And then the next thing you're going to do is you're going to divide the powers of 10. But when you divide the powers of 10, you keep the 10. And what you do is you subtract the exponents. Okay? Now when you subtract the exponents, careful putting the numbers in the calculator. So here's my subtraction. I did negative 30, take away negative 32, and you can see it's positive 2. And that's how you do the first problem. In the next problem, problem number 2, they're asking you to use this formula, okay, which basically is going to calculate the frequency based on the speed of the light and the what is called the wavelength. Okay, that weird symbol is a mathematical symbol called lambda. Basically, what we're going to do is divide the speed, which in this case is 3 times 8, 3 times 10 to the 8 power, by the wavelength, 5 times 10 to the negative 7 power. But I changed the numbers, okay? So instead of 3 times 10 to the 8, I use 4 times 10 to the 9. And instead of 5 times 10 to the negative 7, I use 8 times 10 to the negative 8 power. The same way we did in the previous problem, the way you divide the coefficients. I didn't want to do that. You divide the coefficients, 4 divided by 8. You take a calculator, you're going to get 0.5. Okay. Then you're going to divide the powers of 10. So you're going to divide 10 to the 9th power divided by 10 to the negative 8 power. What you're going to do is you're going to keep the 10. I kept the 10. And using the calculator, okay, again, careful when you're doing this using the calculator. You're going to subtract 9, take away negative 8. And you can see it's 17. Now, here's the problem now. Your final answer here is not in scientific notation because this number, 0.5, is not between 1 and 10. So what you're going to do, you're going to move the decimal, because this is a small number, we're going to move the decimal point to the right. So now it's going to be all the way on the right end. So now we have 5 point. We're going to keep times 10. But when you move to the right, the decimal point you're subtracting from the exponent of the 10. So now we have exponent 16. Okay, and that's how you do problem number 2. And problem number 3, we're going to continue dividing like I have done in the other problems. First 2, you're going to divide the coefficients with the coefficients. So 42.5 divided by 5. So let's get the calculator right away. So I'm going to divide 42.5 divided by 5. And I got 8.5. So let me write this down. So I got 8.5. And the next thing I'm going to do is I'm going to divide the powers of 10 with the powers of 10. So I'm going to divide the powers of 10 with the powers of 10. So I keep the 10. And again, careful when you're subtracting the exponents. Okay, because when you are dividing powers of 10, you're going to subtract the exponents. So you're going to do negative 12. You're going to subtract negative 24. And you can see I got positive 12. Okay, so that's how you do problem number 3. Of course, I changed the numbers, so you try your own question 3. Let's go to the next one. Here's question number 4. Again, I'm going to change the numbers. I'm going to give you something similar. So here's the problem number 4 that you're going to be doing. Here's the one that I'm going to show you. They look similar. Same thing I've been doing the last problems about division. We're going to, the way you divide numbers in scientific notation, you divide the coefficients by the coefficients. And you're going to divide the powers of 10 by the powers of 10. So when I'm going to start dividing the coefficient, 5.4 divided by 1.6, if I did it in the calculator, you can see it right there. I got 3.375. Now when I divide the powers of 10, I'm going to keep the 10. And I'm going to subtract the exponents. So using my calculator, let's do it right now. If I subtract negative 15, subtract negative 9. Again, careful when you're writing the exponents in the calculator. You can see I got negative 6. And that's how you do problem number 4. In problem number 5, it's a word problem. It's about how much medicine must be given to a patient based on the weight. What you do is you multiply the weight of the person by how much medicine per kilogram the patient needs. So it's basically a multiplication problem. I changed the numbers. So look at the numbers that I'm using instead of the ones you see in the actual problem. And basically to multiply numbers in scientific notation, you're going to multiply the coefficients with the coefficients. So 3.2 by the 70. Now for that, you're going to have to use the calculator. So let me bring my calculator. So 3.2 times 70. You can see we got 224. Let me bring this up. We got 224, and then we multiply the powers of 10 with the powers of 10. But if you look carefully, the 70 doesn't have a power of 10. Okay, so I'm just going to bring this down because that's the only power of 10 that I have left. Okay, however, this answer, okay, it's not in scientific notation because the 224 is not between 1 and 10. That's one of the requirements for a number to be in scientific notation. So what I'm going to do is I'm going to find the decimal point of 224, which is all the way on the right end. And I want to move it to the left. When the number is bigger than 1, you want to move it to the left. And I want to leave it between the two 2's. So now we're going to have 2.24. Now if I move it 2 times to the left, it means I'm adding 2 to the exponent of the 10. So now it's going to be times 10 to the negative third power. And that's how you do this problem. Problem number 6, another word problem. When you read the problem, it basically is asking you for what is the total mass of the pollutant. If there's 1,000 liters, instead of 1,000, I'm going to use 2,000. And the amount of grams per liter is that number in scientific notation. I change it to this one, 6 times 10 to the negative 8 power. Okay, so to find the total amount, the total mass, what I'm gonna do is I'm gonna multiply the numbers. And like I did in the previous problem, we're gonna multiply the way you multiply numbers in scientific notation. You multiply the coefficients with a coefficient, so 6 times 2,000. When you do that in the calculator, you're going to get 1,200. I'm sorry, not 1,200, 12,000. And the next thing I'm going to do is I'm going to multiply the powers of 10, but 2,000 doesn't have a power of 10 right now. So I'm going to take the times 10 to the negative 8 power. I'm going to put it right after the 12,000. Okay. However, my answer here is not in scientific notation because the 12,000 is not between 1 and 10, like you can see in the template above. So what we're going to do, we're going to take the decimal point of 12,000, that is all the way on the right end, and I'm going to move it to the left until I get a number between 1 and 10. And I'm going to put the decimal point right here between the 1 and the 2. So I'm going to have now 1.2. Ending zeros, we do not write it. Okay. Now, if I move it, I move the decimal point to the left. I think I move it 1, 2, 3, 4 times. I need to add 4 to the exponent of the 10. So I'm going to have times 10 to the negative 4 power. And that's how you work problem number 6. And problem number 7, another word problem. But in this word problem, they gave you a formula, which is the energy of a single photon. Basically, you're going to multiply the H, which is called the Planck's constant. In other words, H, the value of H is always that number, 6.63 times 10 to the negative 34 power. And you're going to multiply by the frequency of light, which in this problem, they gave you this number here, 4.5 times 10 to the 14th power. I change it to a different number. So because again, I'm doing similar problems, so you can do your own. So how do we multiply numbers in scientific notation? Okay, because that's what the formula is doing, multiplying. So what I'm going to do is I'm going to multiply the coefficients with the coefficients. So the 6.3 with a 3.5. Now we're going to have to use the calculator here. Okay, so let's do that right now. 6.63 times 3.5. And you can see I got 23.205. That's how much I got. Let me write that down. And now we're going to multiply the powers of 10 with the powers of 10. Okay. So we're going to keep the 10, so times 10. And what I'm going to do now is when you multiply the powers of 10, what you're doing here is you're adding the exponent. So let's do negative 34 plus 15. That will give me negative 19. However, remember that your final answer should be in scientific notation, but this number, 23.205, is now between 1 and 10. So I'm going to have to move the decimal point of this number, which is right here between the 3 and the 2. I'm going to move it 1 time to the left. You move it to the left when the number is bigger than 1. And I'm going to put it here in between the 2 and the 3. So we're going to have 2.3205. Now, since I move it 1 time to the right, I'm sorry, not to the right, to the left, you're going to add 1 to the exponent. So you're going to have times 10 to the negative 18th power. And that's how you work this problem. In problem number 8, okay, we have a multiplication, 2 numbers in scientific notation. I changed the numbers. Okay, I'm doing something similar, so you can try this on your own, but the process is the same. How you multiply numbers in scientific notation, you multiply the coefficients with the coefficients. So here we go again, we need the calculator here. Let me get my calculator. And I'm going to multiply 3.67 times 4.5. And I got 16.515. Okay, 16.515. And then you're going to multiply the powers of 10 with the powers of 10. But remember, you're going to keep the 10. The way you multiply the powers of 10, you keep the 10 and you add the exponent. So I'm going to do that in the calculator again. So I'm taking the exponent negative 13, I'm going to add the exponent negative 9. And you can see I got negative 22. However, once again, like I have done in the previous problems, always check if your answer is in scientific notation. My answer here, the coefficient, the 16.515, is not between 1 and 10 like the template above says it should be. So what I'm going to do, I'm going to take the decimal point of this number that is between the 6 and the 5, and I'm going to move it 1 time to the left. So I'm going to put it between the 1 and the 6. So I'm going to have a new coefficient, new decimal, 1.6515. Now, when you move the decimal point to the left, you're adding to the exponent. I move it one time to the left. I added 1 to the exponent times 10 to the negative 21st power. And now that's how you do that problem. And for the last problem, problem number 9, we multiplying again numbers in scientific notation like I did in the previous one. I'm going to do the same thing again. The way you multiply numbers in scientific notation, multiply the coefficients with the coefficients. So when you multiply that in the calculator, you're going to get 5.7. And then you multiply the powers of 10 with the powers of 10. So you keep the 10, so times 10, and you add the exponents. Now careful again when you're adding positive and negative numbers in the calculator. So we're going to take the negative 15 and we're going to add negative 20. The number one mistake students do, and I do it all the time, is making mistakes with a negative sign. And you can see I got negative 35th power. And that's how you work this problem.